In this lesson, we'll be adding and subtracting rational expressions. Let's start by reviewing how we add and subtract fractions. To add fractions, we're going to need a common denominator. And so we look at our example, and our two denominators are 10 and 7. They have no common factors. So our common denominator would be 10 times 7, or 70. We would typically get a common denominator of 70 and then rename the fractions with the new numerator. What we're really doing is we're going to multiply each fraction by a disguised form of the number 1. So we're going to take 3 tenths, multiply it by 7 over 7. We're taking 2 sevenths and multiplying it by 10 over 10. Because now this expression is equal to the original sum of the fractions. So now I do have a common denominator of 70, and I can multiply 7 times 3 to get 21 here, and 2 times 10 to get 20. And now I can add my numerators together, and I get 41 over 70. So to subtract fractions, again, we're going to need common denominators. Here, the number 3 goes into 24 evenly. So we can use 24 as our common denominator. We're going to multiply this fraction on the right by 8 over 8 to get a denominator of 24. And now I can subtract my numerators and get negative 5 24ths. So we're going to follow a similar procedure for adding and subtracting rational expressions. Whatever the rational expressions are that we'll be adding, we're going to get a common denominator by multiplying each rational expression by some disguised form of the number 1. So here's our first example. We don't have common denominators. I have x and I have x plus 3. So the denominator I'm going to need is x times x plus 3. The fraction on the left, the rational expression on the left, I'm going to multiply by x plus 3 over x plus 3. And the expression on the right, I'm multiplying by x over x. Now, when we look at our denominators, we have x times x plus 3. That's the common denominator. And I'm going to rewrite this so that the denominators are common. And I'm fixing up my numerator, so it's 5 times x plus 3. I'll have to distribute that 5 through there, and 4x. So now I'm going to go ahead and get one single expression with the denominator x times x plus 3. Now I'm going to want to distribute this 5. And finally, I have some like terms, 5x and 4x. That's 9x plus 15. So this would be a very good answer. Some people like to see if there's anything they can factor out of the numerator to see if this fraction or this rational expression will simplify further. There is a factor of 3 in my numerator, so 3 times 3x plus 5 over x times x plus 3. Now that is as far as I can take this. I cannot cross cancel here the x's. I cannot just cancel out this 3 with that 3 because these are factors, and the only way I can cancel out factors is if they match exactly. So now we will subtract rational expressions. And I have a little bit more complicated denominators here, but I'm looking at this x squared minus 25, and I'm remembering this can be factored as the difference. This is the difference of perfect squares, right? So it can be factored as x plus 5 times x minus 5. And now that I've done that, I can see that the x minus 5 is common to both rational expressions. So really, to get a common denominator, I just need to multiply this one by x plus 5 over x plus 5. And now that I've done that, my denominators are matching. So I'll just write them as a single denominator, remembering this 7 is going to be multiplying by this binomial, so I'll put it in front, remembering to distribute it. I'm subtracting off a binomial, so I really do need the parentheses here. So once I've distributed the 7 and distributed the minus sign, I get 7x plus 35 minus x minus 3. Now I can combine my like terms and get 6x plus 32 over that denominator, x minus 5 times x plus 5. And once again, that's a good answer. Some people like to factor the numerator one more time. Seeing that there is a common factor of 2, I can pull that out. So 2 times 3x plus 16 over x minus 5 times x plus 5.